Hello and welcome to our interview about 3D printing.
All right, we're here with a very special guest today, a student from Penn State University.
You're from Penn State, right?
Working with.
I am from Penn State, yes.
Is it fun?
Is college fun or is Penn State fun?
Both.
Both.
It's a lot of work, but it has its rewards.
All right. So.
Thank you for being here. So we're going to start off with asking some questions. So,
what interest got you into 3D printing in the first place?
What got me into 3D printing? So actually at my high school, we had some 3D printers, which is where I originally kind of got started and just got really interested into it. So, and I was doing a project helping out a disabled student. So I actually made a trumpet that basically the valves actuate themselves with buttons. So I 3D printed a basically enclosure for that, and then a clip to go on the trumpet. So that entire ordeal helped me refine my engineering skills, and 3D printing was a very good tool for that situation.
All right, thank you. Now, so what are the things that you are currently creating with this technology?
I have a couple things here actually with me. You can see here, this is actually a 3D model of a rocket.
wow.
Nice.
Yep. So it's exactly a 1-to-1 scale of the rockets that we're using for a craft for a project here at Penn State. So that's just a 3D model that I made for that. And then actually, so this is made out of plastic, so it's PLA. It's biodegradable. I don't know how much research you guys have done with 3D printing. Have you guys researched online about different
Yeah.
So how much do you guys know about different printers and different types of plastics that different printers can use?
We know a little bit, yeah.
No.
Pretty much like, so, depending on if it's like plastic or the metal, some printers can pretty much use it like the dust and fuse them together, while some can take, like the liquid form, and they can rise up from that, and they can see accurate stuff like that. So.
Yep. So there's three, or really just two main different types of plastic printers. You have your FDM, which is basically you start out with a spool of plastic. So here, I'll take you guys over and show you the printers that we have here. So you kind of see there's two that we got here, and you can see it uses a roll of plastic like this.
Mm-hmm.
So this is almost empty. So it just, one second here. See that?
Yeah.
Yeah.
That's what it starts out as on this roll. And then, I'll show you this. So this is an extruder. Can you see this here?
Yeah.
Yep. Okay, so this is the hot end here. This is what gets up to about 230 degrees Celsius. I don't know how much you guys can see. Yep. So the plastic, which is right here, goes in, gets heated up, and then comes out this little nozzle. So that's how that all works. And then there's a gantry system, which you can see here, that moves the nozzle around, which then puts it layer by layer down.
Nice.
So that's how that generally works. And that's just one of the nozzles that we take it apart to fix. So that's FDM. And then you have your liquid printing, which starts out as a liquid, and then you use a laser to cure that. So there's actually some other parts that I've made with that type of printer, which are right here. So you can't really tell. So this blue part is made with the FDM, which is the printer that you just saw. But the little white parts, those little, really, really small engines. So there's my finger right next to it.
Yep.
And you can see how much detail that gets.
Oh, yeah.
Yeah.
Really, really detailed. So it's called SLA, So that's what the liquid printer is. It's called SLA, and you can get really, really fine detail because you're using a laser instead of just a little nozzle.
Yeah.
That's the difference there. It's also a lot more expensive.
Yeah.
What do you plan on doing in the future with 3D printing?
Like, as in, like, career-wise.
Well, eventually I want to go work at SpaceX, and they actually 3D print their rockets.
Yeah.
So actually,
I was gonna go to space.
actually we 3D printed one of our rockets here as well. This is a 3D printed out of metal. So we didn't use the printers that we have here in this lab, but in another lab that's at Penn State, we used a metal printer that, so this starts out as powder, really, really fine powder. So fine, in fact, that if it got into the air, it could catch the air on fire.
Wow.
And you don't want to breathe it in, so you have to wear respirators when you're working with that. So it's not exactly fun stuff, and it's not cheap either. This part here costs about $2,500 to print, and that's at cost. So other companies would have to pay more for that. So you can kind of see similarities here.
Yep.
That's kind of how that. Well, go like that. Yep.
Yeah.
So. Yep. Go ahead.
How often do you yourself use 3D printing? Is it like every day or like once a week?
Depends on what I'm doing. Sometimes I could spend a whole entire day just working on a part and just printing out different things. There was 1 week I was making a centerpiece for a table for a event we were going to. So I ended up printing out 40 of the same thing. So I had about 6 printers printing all at the same time. So I was running from, they were in 2 different labs, and of course they were across campus. So I was running back and forth, making sure everything was printing. So it took me about a week to print everything, which was, that was a lot.
Yep.
But typically, I don't print too often, maybe a couple times a week, depending on what I'm doing, depending if I have a lot of other work that I need to get done. So it really depends on what's going on.
And you said you used FDM, SLS, and SLA printing?
So SLS is the metal. So SLS is selective laser sintering, and technically this part is selective laser melted. So SLM. There's a difference there because SLM gets you about 100% density, whereas SLS gets you probably 70-60% density. So when you're making a part out of metal that you actually want to use in a real application, you want something that's close to 100% density, like if you were actually making it through subtractive manufacturing.
Okay.
So, yep.
How do you feel 3D printing impacts the industry and economy in America?
Economy. So, I don't know if you guys know this or not, but 3D printing or additive manufacturing is actually not new. It was first started with SLA back in the, I believe, 60s, 70s, but it cost a whole lot of money. So just now, in the past 5-10 years, has the cost come down for FDM so much that people, tinkerers, and just small shops can purchase these printers or build them themselves and print. So you can go out and buy a pretty good printer for $2,000 or make one yourself for $500. So I don't think it'll really impact the industry too much. I think the industry is safe because when you're making things on a large scale, regular subtractive manufacturing or injection molded parts are a lot more durable and also a lot cheaper to make, and you can make them a whole lot faster. But 3D printing is really good for doing prototyping or making small production runs of some product or something that's really, really intricate. So like a rocket engine that's really, really advanced. It's really difficult to do intricate work like that quickly. So it's actually easier and more cost-effective to print it.
Yeah.
What do you think 3D printing will eventually become?
What do you mean by that?
Like, at the moment, they're making the plastic and metal bits, and they are making printers to print organs for transplants. And then I researched a printer that's printing food.
Yep.
Do you think it could eventually become something that could create, like, even computers itself, like, just with the plastic that it's using?
Or like something like that.
Yeah.
Well, you wouldn't be able to use plastic because typically plastic is an insulator, not so much as a conductor. So with a circuit board, you need things to be conducting.
Yeah.
And you won't see 3D printers making computer parts because computer parts are extremely small. So even if you take apart your computer and you see that little microchip, that microchip is just, it's mind-bogglingly small. You wouldn't be able to print that for thousands of years probably, or if ever. That kind of stuff is really, really far out if it's even possible. But in the near future, 3D printing will make prototyping a lot easier, and you'll see a lot more households have a small 3D printer, and a lot more labs have that just for ease of prototyping and just making small models of things.
How long has it taken you to, like, master 3D printing?
Uh-oh, the light ran out.
Hold on.
All right, well, I can still hear you, so.
Okay.
Okay, we're
All
back.
right, you're back. So, I mean, it doesn't take too long. I mean, it depends on what printer you're using. So the MakerBots, you guys know MakerBot?
Yeah.
A little, yeah.
Yeah. So their printers are pretty user-friendly, really easy to get started on. That's what I started out on. They have their own closed systems. They provide you the software. They provide you with the printer ready to go out of the box. And they have pretty good customer service. So if anything goes wrong, you can go to those guys and they'll help you out. So that's really, really easy to master because you just make the 3D model and then you print it. And that's pretty much all you got to do. So a lot of the learning curve is on the modeling side. And that's what takes a little bit longer, is doing the 3D modeling. So once you can master that, 3D printing becomes a lot easier.
Now, I said you were going to work at, or you wanted to work at SpaceX, right?
Correct.
So, I want to work at SpaceX as an astronautical engineer, eventually, if I can get that far. Now, what do you think the benefits of having a 3D printer in space are for food or parts?
So, I don't know if you heard or not, but on the International Space Station, just about a month ago or so.
Yes.
They started printing food, didn't they?
No.
They sent up a printer in November, right?
So somewhere around there, in the late fall, early winter, they sent up a printer on actually a SpaceX Falcon 9 rocket, and they printed out a couple things. They printed out a little wrench just because they can. So what's really good about that is you can send up CAD files through their network onto the International Space Station, and then they can print it out there instead of waiting a couple months until the next launch to be able to get stuff. Yeah. So if you need a part right now, and you don't have a fabrication shop, you don't have welders and drill presses and saws and stuff on the International Space Station, so you need some way to make a part now.
Yeah.
And that's where the 3D printer comes really in handy, because you can have all your teams of engineers on the ground on Earth make that part for you, and then all you have to do is press print, and you wait a couple hours, and then there's your part. Yeah. So that's where it becomes really handy for space. I don't see food being a really making sense. It doesn't make any sense to me at all. Just except for fun. If you want to make something out of chocolate, that's the only.
Yeah, Hershey's
is doing that.
Yeah.
I did some research, and SpaceX is the one sending people to Mars, right?
Not yet, no. That's their goal. So hopefully in the next 10, 15, 20 years they'll be able to do that.
Yeah.
Right now.
I read they were sticking a 3D printer for food on the ship with a bunch of raw materials, so they didn't have to eat the freeze-dried and pre-packaged food. You know.
Yeah. So that isn't.
Oh my god. Frick, I hope I didn't miss the call.
Are you still there?
Call on hold. Oops.
Oh.
Yeah, sorry.
All right. So, as I was just saying earlier, 3D printing food is not really a viable option, I guess, or it doesn't make a whole lot of sense.
Yeah.
But 3D printing out of other materials is a lot. It still has a lot of exploration to be made. So.
Yeah.
Okay. I think we have to go.
Yeah, thanks for
Thank you
helping
for
us out.
having us. Yeah.
Sure.
Thank you.
So,
Yep.
yeah, bye. Bye.
Yep. Yeah.
Alrighty.
Thank you.
Thank you so much.
Thank you.